Okay, so as promised, example number 1. So we had our givens written down and it wants to know what's the distance traveled. So you have a VI, an A, and a delta T, and you want to solve for delta D. So you'd use this first equation because it has everything you need in it. Don't use the VF squared equation because you don't have VF squared. Okay, so go with delta D is equal to VI delta T plus 1/2 A delta T squared. And look, I was nice in this first one. You don't even have to rearrange it. It's already set up for delta D. So VI is 80 meters per second. Time is 10 seconds. Plus 1/2 A is 2 meters per second squared. And time is 10 seconds squared. So 80 times 10 is 800. Meters per second times seconds, the seconds are going to cancel, so that's going to be meters, plus 1/2. Now what gets squared here? Only the delta T. So 10 seconds squared will be 100 seconds squared. Half of 2 will be 1, and 1 times 100 will be 100. Meters per second squared times seconds squared, the seconds squared will cancel, and we'll be left with meters, which is a good thing because that means we can add these two together. And you're looking for distance traveled, it should be in meters. So 900 meters is the answer to the first part. Now I decided to be nice and I didn't put any directions in. I made these all scalars, like I talked about speed. I could have easily said 80 meters per second east and 2 meters per second squared east, in which case then this delta D would have been east. We're not finished though, because it wants to know what's the plane's final velocity. So this was part A. For final velocity, now I would use this guy. Okay? Should probably have boxed them earlier. All right, so for part B then, use VF squared is equal to VI squared plus 2A delta D. And again, you don't even have to rearrange. Don't get lulled into a false sense of anything. You will have to rearrange other ones. So VI was 80 meters per second. And that's squared. Plus 2 times A was 2 meters per second squared. And our delta D we just found, it was 900 meters. So VF squared equals 80 squared is 6400 meters squared per second squared, plus 2 times 2 is 4, 4 times 9 is 36 with 2 zeros. Meters times meters is meters squared, and the second squared stay on the bottom. So we get a VF squared is equal to 10,000 meters squared per second squared, and now take the square root of both sides. VF equals, now if it was a vector, we would write plus or minus, and then we would figure out did we want the positive direction or the negative direction. But since I didn't put any directions at all in the question, you can just go to 100 meters per second because it's asking, oh, it does say final velocity, but I didn't give you any directions, so you can't put it, so it would be 100 meters per second in the original direction, even though I didn't tell you what that was. All right, so now for example 2 and 3, I'd like you to do those, and I'd like you to do the first 6 on this page, okay, which is the other sheet I gave you today. Tomorrow's videos will do these 2 and do these 6. If you're having issues, those videos will be up before long, so you could always watch the videos for these 2 examples and then try these 6 on your own or something, okay? But give it a shot. I've used both equations for you now. Write down the givens, figure out which equation to start with. They'll get better. Don't stress because this is just the beginning. You'll get really good at these, promise.